The city of Portsmouth has an amazing history of dynamic change over the last 350 years, and the community's spirit of adaptability has generated technical innovations and tells the story of a port that has evolved, today to be a crucible for new ideas and engineering techniques. A port shaped by history, a history shaped by the port. Thanks for your time today, and I look forward to bringing you along through a rich history of how technological change shaped the port into what it is today. First, we will talk about when this story starts in the 17th century. Then we will review the port as an agency responsible for the stewarding change and facilitating waterborne commerce. Finally, we will look at the port's concerted investment in infrastructure, improvements to prepare for future generations to build on this history. Early days of the port focused on shipbuilding, which Portsmouth had an enormous role. In fact, in 1691, English law declared all pines greater than 24 inches were the property of the crown, and marked by hatchet with a broad arrow to be used later for the king's shipbuilding ambitions. Discontent with this English law on the timber resources is one of the early pressures leading to the Revolutionary War. All around the seacoast, you see remnants of this law by the naming of mass roads used for the hauling of tall trees to the seaport, destined to be used as ships. Portsmouth, in the 19th century, bustling with commerce, and the Piscataway River, a vital link to trade locally and down the coast and over to Europe. This perspective of Portsmouth depicts the tugs where they are today, and the ferry is coming from the location of the current ferry landing restaurant. In the background is a large schooner unloading coal at the Walker Coal Pocket. The historical and charming fabric of Portsmouth you know today is shaped by the seaport. The charm of the brick is a remnant of an available local resource at the time, and a fire act after the Great Fire of 1813 requiring all buildings be constructed of brick. The shipyard located within the port has been a cornerstone of the harbor since its founding in 1800 under the John Adams administration. Pictured here is an innovation in engineering, a large floating wooden dry dock for the construction of war vessels. This dry dock is now long gone, and towards the end of the 19th century, the Navy started the construction of a new dock, this time a graving dock. This type of dock is constructed as a basin built into the ground and required the removal of blasting of 166,000 cubic yards of soil and rock. This dock has proven the test of time and is still in operation today, and the yard's largest operating dry dock. I had the honor back in 2010 to serve as a designer of record on a major upgrade to this magnificent marvel of engineering. The yard with a proud history of firsts and innovations, but do not let me get distracted. We will continue our journey through time about the port. An important piece of the story is the development of the Federal Channel and the vessels that shaped the port over the last 350 years. The Piscataway River, the lifeblood of one of the more influential ports during the colonial era, was a nightmare for a captain to navigate. Rocky shorelines, a twisting and turning path, and treacherous currents of 5 knots. The river's name comes from the local Abenaki inhabitants, meaning a river with strong currents. Here is an early plan of improvements to the channel undertaken by the Army some 143 years ago. Everything exciting starts with a bang. Our universe, a marathon, and yes, the Port of Portsmouth. A boom for sure. At the time, it was the largest man-made explosion in American history, requiring the careful placement of 50 tons of dynamite. This effort started with a local expansion of the Navy's need for larger warships and the report that some of the captains refused to enter the harbor due to the treacherous point of land. Locally, they called it Pullum Bedam Point. One of the greatest engineering feats of the time, and people traveled for miles and miles to watch the explosion. In fact, 30,000 people gathered to watch the event. Many innovations were documented, from the technique to drill the holes to a great depth, to the largest timber cofferdam at the time, and many, many more. So now let us move on to the evolution of vessels within the port. starting with the gondolas. These navigated the Piscataqua region from 1700 to 1900, first starting as shallow draft flat deck barges that could be rowed, but mostly floated with the tide. Later, they were adapted with a specialty sail that was heavily weighted and could be lowered rapidly to do what they called shooting under the bridges. These early vessels could haul 50 tons of material and often carried cattle, bricks, lumber, and other cargo. Moving along in the evolution of vessels, pictured here in 1908 is a schooner, Paul Palmer. The keel was laid in 1902 by the George Welt Company in Waldoboro, Maine, a renowned town for shipbuilding. In the picture, the vessel is docked at the Walker Coal Pocket in downtown Portsmouth with an overall length of 276 feet and a draft of 24 feet. This vessel, a true king of the sea with the ability to carry over 2,000 tons and traverse the ocean. However, the Paul Palmer's life was short, and on a trip south to Norfolk for a load of coal, its fate was sealed. On the return voyage, it caught fire and was a total loss. The crew, including the captain's wife, were saved, reportedly by a vessel out of Provincetown, Massachusetts. Let us move forward to a new chapter and larger vessels. The growing automotive industry saw a need for fuel and lube oil, and pictured here is the mobile fuel built in 1939 by Bethlehem Steel at the Sparrows Point Yard in Baltimore. This vessel was the basis for the widely built T2 tanker during World War II. These tankers, pivotal for the war's success and set records for low cost and speed of fabrication, with over 500 built in 5 short years. However, rapidly built during wartime, they were later discovered to be prone to cracking in cold weather. In February 1952, 2 of these tankers, the Pendleton and Fort Mercer, cracked in half and failed in the same evening storm. If you're interested to learn more, a great book about the incident I read is The Finest Hours by Michael Tugas. Now, if you recall, the Paul Palmer had a capacity of 2,000 tons. The mobile fuel is 500 feet length overall and has a beam of 68 feet and may carry over 15,000 tons of cargo. The Centennial Forza, a modern Panamax-class vessel, the largest vessel class able to safely transit the river and specifically designed to fit through the old Panama Canal. With a beam of 106 feet and a length of over 600 feet, this vessel is a bulker, as you can tell, with the onboard cranes and cargo hatches. In this picture, it's approaching the dock at Sprague River Road Terminal, intending to offload gypsum rock for the manufacturing of drywall. This vessel may carry over 50,000 tons of cargo and is representative of the contemporary class of vessels navigating the Piscataqua River. In this picture, we're looking at the contemporary federal channel from the mouth of the Piscataqua River to the farthest reaches at the upriver turning basin. The modern federal channel is over 6 miles long, 400 to 600 feet wide, and has a safe depth of 35 feet at low tide. The area in red at the top end of the channel is an active project to expand the turning basin to accommodate growing vessels. Currently, the ships only have a few feet to shoehorn the turn for a safe voyage out the river. The ships on the river are safely maneuvered by local river pilots who meet the vessels out at sea, and the captain of the ship steps aside and lets the pilot with local knowledge take control. Vessels of this size are only able to transit during periods of slack water, which occurs every 6 hours, and once the voyage starts, the pilot is committed due to the limited time of calm water. The river is an economic engine supporting local businesses that receive and ship cargo for their lifeblood. For example, a Newington company is a leader in the manufacturing of undersea cable shipped around the world and used by the military. So now let's focus in on the Port Authority. We are now looking at Noble Island in the center of the slide. where the Port Authority is today. In the background is the old timber bridge crossing the Piscataqua and the Portsmouth Street Railway building in the center. The timber bridge was known as the Wiggly Bridge, and one night lived up to its name when a train went over the side, and it still rests on the bottom of the river today. The state in 1957 passed legislation to establish the Port Authority and purchase the land, which is now the Market Street Terminal, from the Standard Oil Company and the Boston and Maine Railroad. In the picture, you can see the state of the site with derelict vessels along the shoreline. Here in 1964, the derelict vessels have been removed and construction is starting on the first section of the wharf. At the time, the techniques used were state-of-the-art, establishing piles deep into the bedrock to resist river currents and ice. 57 years later, this section of dock is still in use today. Now in 1977, the port is doing well and is looking to expand to better support the current class of vessels with a much needed expansion, adding an additional 276 feet to the north end of the dock. The expansion set the stage for the next 40 years. However, the proximity of the wharf to the bridge proved to be a challenge for vessel captains as vessels continue to grow. Unlike a truck, you do not have the leisure of a parking brake, and the shifting currents and tides made holding the ship on the dock a challenge every day. This image shows the configuration in 1995 after the construction of the barge dock to the right. And I would note the bridge bisecting the port through the center of the slide. In 2001, the port was merged with Pease Development Authority, providing flexibility and latitude to foster and develop port business. This is truly a unique arrangement in the maritime industry, allowing the port to step in as a terminal operator, thus doing what is right for the local economy and supporting many private businesses. The port is now focusing on fostering growth of the maritime business and propelling the state economically. Let us delve into some of the more recent projects. Here is a vessel unloading wind tower parts for a project in Berlin, New Hampshire. These large and heavy components come in by water due to their size and are shipped piece by truck. You will note in this slide the open water between the wharf and shore, a true impediment to safe and efficient transfer of cargo, and a goal to resolve in one of our current design projects. Now, a large crane is unloading a dry dock entrance. This gate is to be used on a construction project at the Navy Yard. Eric Levesque, one of our engineers serving as the designer of record for this project, is observing the unloading of this 650-ton piece of equipment. This was manufactured in Norfolk, Virginia, loaded on a barge, and floated to the Port Authority for unloading. The gate, called a caisson, can float and sink to act as a door between the dry dock and the ocean by the flooding and dewatering of internal chambers. This heavy lift is just one small part of the wide range of projects at the port. A cargo vessel, the Holland Pearl, is unloading aggregate to support a contractor who is working on a $160 million project to expand the Navy's submarine repair capabilities. This project, when completed, will place over 45,000 cubic yards of concrete, and these massive piles of aggregate will feed a mobile floating concrete batch plant. To say that differently, it equates to the same volume as 4,500 cement trucks, and all the material as the aggregate in this slide will be delivered through the port. In the background, under the black tarp, and further on, the large white pile are many tons of road salt to be used during winter months. Pictured here is the christening of the USS Manchester, an Independence-class littoral combat vessel. Okay, so how about a little trivia? The sponsor for the vessel is our Senator, Jean Shaheen, and her initials were actually welded into the hull during the traditional keel laying event. The projects at the Port Authority are wide-ranging, and in fact, the fabrication of much of the precast for the new middle bridge was completed at the port. In this image is a hoisting of a nuclear power plant component manufactured in Newington at Westinghouse Electric. With the port facilities, this local business thrives, shipping its products around the world. It's an interesting period right now at the port, with growing interest to invest in infrastructure. We are deep in the engineering and anticipate being constructing for the future soon. A wide range of engineering studies have been completed to provide a better understanding of the existing conditions at the site. These engineering projects have been completed with the support from many other ACEC member firms that are close partners to Appledore Marine. As a specialized firm, we rely on this group of quality firms. In this picture is a high-resolution multi-beam survey to describe the elevations of the river bottom. This technology uses millions of sound beams to bounce off the bottom and record the exact position based on the return sound wave. Remarkably, the accuracy of these surveys is quite good. We also used our in-house divers to set up an underwater Doppler current meter to measure the precise current vectors of the river. We attached the meter underwater to a wharf caisson, allowing the measurements of the current well into the river. You can see an example of a Doppler current meter in the top right of this slide. So now let's move above the waterline. We used a range of drone and other specialized survey techniques to map the site. On left is Dan Del Tufo, one of our newest professional engineers, recording data using his iPad, an investment we made in purchasing for all employees to lead to more innovation and lower cost in collecting information. On the right is a LiDAR image from the drone, and on the top is an image created with a handheld LiDAR device called the GeoSlam. One of our engineers, Luke Harris, used this and gained remarkable accuracy of the existing conditions. Our in-house engineer divers collected detailed measurements above and underwater of the existing geometry. These detailed measurements set the groundwork for a comprehensive bid package. In addition to tactile inspections and measurements, concrete coring of structural elements and material testing guided the design and specifications. We also completed a mooring and berthing analyses to determine the forces applied to the wharf from the moored vessel. These include large compression forces during docking and tension loads on the mooring lines from wind and currents. This analysis and knowledge are essential to secure a vessel at this challenging location. For example, our current study identified a current eddy at the stern of the vessel producing over 570 kips of thrust during the spring tide. This analysis required the use of a specialized maritime software called Optimore, allowing the understanding of forces on a component level basis. Our traditional force diagram in the design of maritime structures includes evaluating forces from a variety of environmental and operational conditions. For this facility, it will be designed for a uniform live load of 1,000 pounds per square foot and 140-ton mobile crane. The design lateral load is 750 kips. Keeping in mind the force is applied unequally with 500 kips on the vessel's stern. Moving on to the supports of the structure. The drilled shafts are designed to support 655 kips axially and a moment 921 foot kips. It's important to note that maritime structures are not governed by codes such as AASHTO or the IBC, and therefore we use best practices and guides. The military is a good resource providing general guidance within the Unified Facility Criteria. And for this project, we referred to the guides 4-152-01, Design, Piers and Wharfs, and 4-151-10, General Criteria for Waterfront Construction. The latter, Appledore Marine recently researched and updated for the industry use under a contract with the U.S. Navy. The supports for this structure will be large diameter caissons. Planning for future generations, the port is making a large investment in the main wharf. You will note the middle bridge is now moved, no longer bisecting the port. It's now off to the far right of the slide. This was an important first step. The key elements of the improvement involve, first, the removal of the failed bridge and the existing harbor master facilities. Next, the shoreside knoll bisecting the north and south sides of the Port Authority is flattened and paved. New sections of the dock are constructed and a contemporary fender system installed. Lastly, the existing wharf is rehabilitated, providing a service life extension. While the improvements to the wharf are completed, dredging and blasting of the berth is undertaken to accommodate deep draft vessels. The dredge material has been tested and approved to be placed at an offshore ocean disposal site near the Isles of Shoals. This facility is designed with state-of-the-art concrete and corrosion protection of steel piles with fiberglass and epoxy claddings. Underwater, cathodic protection will protect the caissons against corrosion. The cathodic protection is a specialty system consisting of two different metals that will interact electrically, one of the metals sacrificing itself to protect the other. In this case, we selected an aluminum alloy as a sacrificing metal for long life to protect the caissons. These features are an important element of a dock designed to unload salt and located in the coastal river. Portsmouth has an amazing history of dynamic change over the last 350 years, owing to fleet advancements, new navigational requirements, and challenging geotechnical conditions. This spirit of adaptability has generated technical innovation and tells a story of a port community that has evolved. Today, a crucible for new ideas and engineering techniques. The next few decades will be no less dynamic, with shifting state demographics enabled by advancing network technologies, and offshore wind industry just getting its footing, and the Navy's $20 billion program to rebuild our nation's shipyards. The port is well positioned to continue to bring about engineering technology innovations to solve tomorrow's waterborne commerce challenges. Thank you.